In this video, I will solve two applications, one dealing with operations of functions and the other dealing with composition of functions. So operations on functions and composition of functions can be applied to everyday scenarios. One application we're going to look at is from the business world, dealing with profit. And we've talked about profit in an earlier section, in fact on modeling with linear functions. If you recall, profit is revenue minus cost. So this is where we can write P of x is equal to R of x minus C of x, but in the terminology that we were just using, that's this expression R minus C of x, right? So this is R of x minus C of x. In this example, we have the fixed cost to produce X units of an item each month is $1,000. It costs $35 to produce each item, and each item sells for $150. We want to write the cost function C, the revenue function R, the profit function P, and then determine how many units must be sold each month to make money. So the cost function is the C of x, which is equal to fixed cost plus variable cost. The thing that we know is that there are fixed costs associated with this production, and that is $1,000 each month. And then it costs $35 to produce each item. Therefore, our cost is the cost per item, which is 35x, plus the cost in a month, which is $1,000. The revenue function is a function that tells us how much money we make from selling X items. If we sell each item for $150, then the amount of money we make is 150 times the number we sell, X. Then the profit function P is revenue minus cost. Right, profit is what you have left over after you pay all of your bills, so to speak. So this is 150x minus, but be careful, just like we saw with the difference of functions earlier, we have to put that expression in parentheses. So 150x minus, in parentheses, 35x plus 1,000. And then we can distribute by the -1 to get 150x minus 35x minus 1,000. And therefore, our profit function is 115x minus 1,000. Now part D says to determine how many units must be sold each month to make money. Well, to make money means our profit is going to be positive, right? We want to figure out when is our profit equal to 0, and then anything more than that will let us make money. So we set 115x minus 1,000 equal to 0, and this is where we will break even. So we can add 1,000 to each side to get 115x equals 1,000, and then divide by 115, and we get an approximation of 8.7. And we can't make a partial item, so when we sell 9 items, we will break even. So how many units must be sold each month to make money? Well, we will need to sell more than 9 items. Now, another example is going to deal with composition. So we suppose that we make $14 an hour, and you have to pay 15% of your monthly gross income in federal taxes. We want to write a function G that represents a monthly gross income based on X, the number of hours worked in a month. Then write a function T that represents the federal taxes owed on a monthly income of I dollars. And then we'll write a function F that represents the total amount owed in taxes for working X hours in a month. Then suppose you work 150 hours in a month. What is your gross income? and compute how much you owe in taxes each month for working 150 hours. So let's go back and address these questions. To write a function g that represents a monthly gross income based on the number of hours we worked, then g of x is going to be, well, our hourly rate, which is 14, times the number of hours we worked, which is x, so just 14x. The function t that represents the taxes owed on a monthly income of $i, well, notice that we have to pay 15% of our monthly gross income in federal taxes. So this function will be t of I, which is equal to 0.15 times our monthly income I. And then we want to write a function x that represents the total amount owed in taxes for working x hours in a month. So now we're looking at what f of x is, but to get the total amount of taxes, we first have to compute what our monthly gross income is and then figure out the taxes on that. So this is where we see the composition take place. So to find the total amount of taxes for working x hours, we're going to have to find the taxes on our income, which is based on x hours. So this would be equivalent to t of g of x, which is 14x. And then if you want to plug 14x now into the function t, right, this would be 0.15. Our income, in this case, is 14x. And this becomes 2.1x. So now this function f gives us a way to determine the taxes based on the hours. Right before, we would have to know the hours, find our income, then plug the income in to figure out the taxes. So this composite function tells us how to go directly from hours to the taxes. Part D says, suppose you work 150 hours in a month, what is your gross income? So here we're just trying to find 150 is our input, the gross income, that goes back to our function g. So to answer part D, we're just going to find g of 150, and that is 14 times 150, which is $2,100. Okay, so that is our gross income for working 150 hours in a month. Now compute how much you owe in taxes each month for working 150 hours. So there's two ways to do this. I could just find f of 150, right? Because f is a function that tells me how much do I owe in taxes for working x hours. So I could compute f of 150, which is 2.1 times 150, which is $315. Now, an alternate way to do that is, I know how much income I made, which was $2,100, right? So g of 150 we found was $2,100. Then I could find what is the taxes on $2,100, which would be 0.15 times 2,100, which is also $315.